Welcome to the second video of Chapter 6. Previously, we had looked at exponential expressions, using properties of exponents to simplify the expressions. Today, we're going to continue with polynomials. We're going to learn what is a polynomial, what the degree of a polynomial means, and then we'll look at some operations with polynomials. So let's start with what is a polynomial. It's an expression that can have constants, variables, and exponents that can be combined using addition, subtraction, multiplication, and division, but there's no division by a variable, and a variable's exponents can only be 0, 1, 2, 3, so only positive numbers. So we don't have any division by a variable, and we don't have any negative exponents. Along with polynomials, we need to be able to identify the degree of a polynomial. The degree of a polynomial is the highest exponent, or combined exponent of a term. So you'll look at all the terms and find the highest exponent. For example, x squared minus 4x plus 62. Here our exponent is 2. Here our exponent is 1. 62, it's really like it has x to the 0. Highest number is 2, or highest exponent is 2. So this is a second degree polynomial. Okay, so let's move on. In example 1, we are determining, is the expression a polynomial, yes or no? And then if it is, what is the degree? Okay, so let's take a look at example A. First thing we need to determine, is this a polynomial? So, do we have any division by a variable? No. Are all of our exponents 0, 1, 2, 3, etc.? Are they whole numbers and are they positive? Well, that's the one that doesn't fly here. Square root of c. That's a power of 1/2. 1/2, not possible. We need only whole numbers. So this is not a polynomial. If we look at B, in this case, do we have division by any variables? No. Do we have any negative exponents? No. Are all of our exponents positive and whole numbers? Yes. Okay, so then what we're going to do is we're going to look at the exponents of each term. This first term has an exponent of 5. Second term has a 2 and a 7, which combines to be a 9. So we say, yes, this is a polynomial with a degree of 9. Now, just so you know what's coming up, you're also going to be asked for the lead coefficient. The lead coefficient is the coefficient in front of the monomial that has the highest degree. So we already said our monomial with the highest degree is a 9th degree. Coefficient out in front is 3/4. So that's a little bit of a preview of what you are going to see in the future in this chapter and in coming chapters. So that's identifying polynomials. We also need to be able to perform operations. So you can simplify a polynomial just like you would simplify a monomial. You're going to perform the order of operations, or perform the operations, and combine like terms. So if we look at example 2, our first example is a multiplication example. This is just distribution. So we are going to distribute that negative 2d. Negative 2 and negative 2 is positive 4. D and d cubed is d to the 4th. So remember from our previous notes, we would add those exponents. Then we have negative 2 and negative 11 is positive 22. D and d is d squared. Negative 2 times 20 is negative 40d. And that's the final answer. Don't do more than that. You're done. Part B is again another operation. This time though, we're subtracting. So what I'm going to do is I'm going to distribute that negative. So I'll end up with a negative 2x squared, a positive 5x, and a negative 3. Bringing down that first polynomial. Now I can combine like terms. So 7x squared and negative 2x squared gives me 5x squared. Negative 3x and positive 5x gives me a 2x. And then lastly, a -1 and a -3 gives me -4. Now you're done here. Don't do extra work. Some students will try to factor this. You don't have to factor. We're not solving. We're just combining like terms. Let's move on to the next page. In example C, this time we are multiplying. Example C, this time we are multiplying. We have a few different options here. Some of you like to draw in arcs like this. I don't like to do that. It gets a little messy. So I use a table. Some of you like to FOIL as well, so you can do that. You got to make sure, though, you multiply every term in the first polynomial by every term in the second polynomial. So if you haven't seen the table yet, here's the way that I like to multiply. I have x squared, -3x, and +6 being multiplied by 2x minus 3. So then, right here, I'm going to be doing x squared times 2x, which will give me 2x to the third. In this box, it'll be -3x times 2x, which is -6x squared, and so on. 6x times 2 is 12x. Now I'm multiplying those top terms, this time though, with -3. So I get -3x squared, +9x, and -18. Last step is to combine all of our like terms. We only have one term that has a cubed in it. We have -3x squared and -6x squared, which is -9x squared. Don't add the exponents. 9x and 12x gives us a 21x minus 18. And we are done. We don't need to factor. We're not solving. We're just multiplying. Okay, example D is the example that you are going to do. Example D is the example that you are going to do. This one, you're multiplying. So my suggestion to you is start by multiplying these two. Then you're going to get some polynomial. Whatever polynomial you get, you're going to multiply by this term. So you can use the box, you can FOIL, you can draw in the arcs. When you turn these notes in, I'm going to make sure that this problem is completed. If you want a few extra examples, you can stay on with me to go over these extra examples at the bottom. This is optional. If you have understood the material up until this point and you feel solid, then you may end the video to try example D. Okay, so we have a few extra examples for us to take a look at. Example A, I just want to know, is this a polynomial? So we got to ask ourselves, do we have any negative exponents? No. Are all of our exponents whole numbers? Yes. Are we dividing by any variables? No, we're not. So we can say that yes, this is a polynomial. And then looking for our degree. We have a 1 here, so the 1 and the 5 gives us a 6. 4 and 3 here gives us a 7. 1 and 1 gives us a 2. So highest combined exponent is a 7. And then remember I gave you a sneak peek at lead coefficient, which is the coefficient in front of the term that has the highest degree. So this is our term with the highest degree. Coefficient in front is a 9. For B, C, and D, we're just performing operations. In B, we're adding. Don't do extra work. Some students think anytime that they see the parentheses they need to multiply. You're not multiplying, just combining like terms. So -3 and 9 gives me 6x squared. 7x and -4x gives me 3x. And -4 and 10 gives me 6. Does this factor? Yes. Do we care? No. Don't do extra work. I'm not asking you to factor. I'm not asking you to solve. Just leave your answer like this. In example C, this time we are subtracting. So you're going to distribute that negative. We get -a cubed plus 3a minus 2. And bring down that first polynomial. And now again, we're combining like terms. So 2a cubed and -a cubed gives me a cubed. 5a and 3a gives me 8a. -7 and -2 gives me -9. We have one more extra example to do. This one is going to involve 2 steps for us. So we're going to notice that we have addition. Before that though, with order of operations, we're going to have to do the multiplication. So we're going to have to distribute, then do the adding. I'm going to start with distributing that 5r. I'm going to get 10r cubed minus 20, r times r is r squared. 5r times 3 is 15r. Now we're to our next term. 3r and 6r is going to be 18r squared. 3r and negative 5 is negative 15r. We're not done. Please make sure you combine like terms. We only have one term that has an r cubed in it. Those 15r's, that's really convenient. They cancel each other out. And then negative 20r squared and 18r squared is negative 2r squared. Again, make sure you're not combining the exponents. So hopefully that was helpful. If you have any questions, please write them down. Make sure that you do the example at the top of the page before you turn these notes in. Good luck.